I guess you'd like your organization to run faster. Most executives would like their organizations to have a faster clock speed, but the problem is that the way management decisions are made by default throughout the organization causes organizations to run slower than they should. And the problem isn't just that organizations run slower, it's that as a consequence they're less profitable, they grow more slowly, and they're less competitive than they possibly could be. So I'm Justin Roff-Marsh. The title of this event is An Ode to Speed, and this morning I'm going to show you how to increase your organization's clock speed by changing your default decision framework. Thank you for coming. I'd like to illustrate how decisions are made in a typical organization using Formula One as an example. In this context, the decision I'm about to describe is obviously idiotic, but you can decide for yourself whether or not the metaphor is appropriate. So imagine that we were to take over the management of a Formula One team, and we were to discover that the team is less profitable than we would like it to be. So in order to fix that, we hire a couple of freshly minted MBAs. So let's imagine that those MBAs do a study of our entire Formula One team, and they focus their attention on the pit crew. And they're surprised to discover that in the pit crew we have 22 operators, responsible for as few as 4 pit stops per race. Imagine 2 cars stopping a minimum of 2 times per race. Now, as you probably know from watching the Formula One show on Netflix, an average pit stop takes about 2 seconds, which means that 22 people collectively are working for 2 seconds times 4 stops per Formula One race. Obviously, there's quite a bit of idle time here, so it's easy to imagine our freshly minted MBAs coming back to us with a report explaining how inefficient this operation is and suggesting that we reduce the size of the Formula One pit crew. Now, there's obviously benefit in doing that. If we have a smaller team, it's easy to imagine that you could reduce the team down to maybe just 5 operators and still have reasonably fast pit stops. You would dramatically reduce the cost of the pit operations, but also you would end up with pit crew members who are more consistently busy rather than 22 people standing around idle all race. Now, I doubt that even MBAs would make a suggestion like that, but if they did, we would dismiss this suggestion out of hand, because we would obviously recognize that improving the efficiency of Formula One pit stops damages the likelihood that we're going to win a race. So I leave it for you to ask the question, is this how decisions are made in your organization? In most organizations, this is exactly how decisions are made. Most organizations are more complex than a Formula One team. In a Formula One team, it's probably obvious to everyone on the team the negative consequences of maximizing the efficiency of the pit crew. But in a large, more complex organization, it isn't so easy to predict the global implications of a decision that you make locally. But you have to make decisions locally, which means you have to optimize for something. If it's impossible for a manager to predict the global implications of a local decision, what tends to happen is they make decisions with a view to optimizing for cost or efficiency, which are functionally the same thing. This results in a decision-making framework that I call the cost-based operating system, and most organizations are running the cost-based operating system. The Formula One team is running what I call the speed-based operating system. Now, it would be easy to conclude that the speed-based operating system doesn't work in larger, more complex organizations. But it does, and it can, and the purpose of this morning's event is to show you exactly how to implement the speed-based operating system in a larger, more complex organization. The essential characteristic of the speed-based operating system is decisions are made with a view to maximizing the speed of the organization as a whole, which is functionally the same as making decisions with a view to maximizing the profitability of the organization. So the speed-based operating system has 3 primary attributes. There's local pit crew behavior. What that means is that in each department or at each operation within your organization, we want operators to operate like the Formula One pit crew. In other words, optimize for speed rather than optimize for efficiency. There's global synchronization. The purpose of global synchronization is to make it obvious to everyone throughout the organization the contribution that the work that they're doing is making or is failing to make to the profitability of the organization as a whole. And then there's the requirement to divide the organization into two discrete subsystems. In this presentation, I'm going to walk you through each of these in turn. But let me start with a warning. In my experience, the second two attributes can add a significant amount of complexity to this discussion, and it's complexity that needs to be there. It's very important that you at the leadership team level understand exactly how this operating system works. However, I don't want you to miss out on the significant benefits that can come from the first attribute, which is installing local pit crew behavior department by department throughout your organization. In my experience, you can get enormous benefit. You can get an enormous boost to the speed and therefore the profitability of your organization if you simply do a good job of installing local pit crew behavior in each department of your organization. So don't allow the complexity to blind you to the opportunity to execute on that first attribute as soon as possible. I'm going to introduce you to each of these attributes in turn. We'll start, of course, with local pit crew behavior, and where this is concerned, it's almost what you don't do that's more important than what you do. So there are three things you need to eliminate. The first is a constant attempt to minimize the size of teams. Teams don't exist to be as inexpensive as possible. Teams exist because they produce value, ultimately for customers. So each of your teams needs to be as large as it needs to be to produce the necessary value. If it doesn't produce value, get rid of it altogether. But if it does produce value and you need to have it, the primary consideration should not be how to make it as small as possible. It should be how to generate the necessary value. Now, on a similar note, busyness does not create value. So you need to eliminate the pursuit of full activation. You need to stop trying to create the state where all of your operators are busy simultaneously. The reality is that availability is a prerequisite for speed. So if you want your organization to run faster, that means operators need to be available. If you imagine what would happen if a fire were to break out and you were to call the fire service, you would expect a truck and a crew to arrive within minutes. And in most metropolitan centers, that's exactly what would happen. 4, 5, 6 minutes later, there would be a fire crew attending to your fire. Now, if you think about why that's possible, it's not because the fire service is efficient. It's the opposite. It's because the fire service is incredibly inefficient. The reality is when you pick up the phone and place that call, there's a very high likelihood that vehicles and crew are standing around idle. If they weren't standing around idle, they wouldn't be able to jump to attention, load into a truck, and get to your location within 3 to 4 minutes. So remember that. Availability is a prerequisite for speed. If you want to speed up your organization, you need to become comfortable with having idle resources. An idle resource is adding value. A busy resource is destroying value. The third thing that you need to eliminate is amorphous assignments. You don't want a situation where operators have to-do lists full of tasks or where operators are working on long-term projects with no readily measurable with no regular measure of achievement. So let's talk about what you should be doing. The first thing that you need to do is to make sure that the work that's being performed by each team consists of discrete packets. As mentioned, you don't want team members working on amorphous assignments. Now, the software industry does a fantastic job of this. A development team might be working on a large, complex application, but that application is broken down into small, discrete work packets called features. And features are small enough that they're inherently measurable, and as a consequence, the team is easy to manage. Now, what's related to the packetization of work is choking the release of work to the team. You should never find an operator with a busy to-do list. At most, operators should be responsible for just 2 or 3 tasks at an absolute maximum. What you want to do is, once you've identified the optimal number of tasks for an operator to be responsible for, is to institute a one-out, one-in policy from that point onwards. So the team member has to complete a task in order to get a new task, and it's the responsibility of the supervisor of this environment to hold back, to choke the release of work packets or tasks to the team. There's no easier way to slow down a team by releasing work to the team at a faster rate than the team members can perform the work. What that leads to is a massive amount of multitasking. The team might feel like they're working faster, but really what's happening is they're busier, and less work in progress goes up and the rate of task completion goes down. So once you've packetized work and choked the release, what you want to do is visualize the rate at which work packets are being completed. An example of that is this dashboard here. This is an application called Insightful that all of our clients use in each of their work groups to visualize work. And typically a screen in Insightful will be set up like this. On the left-hand side, we can see a list of all of the work packets that have been released to team members, all team members. They're color-coded according to their on-time performance. They go from green to yellow to red, and they turn black if they're late. And on the top right-hand side, we can see a chart there showing the percentage of work packets or tickets that are completed on or before schedule. And we'll talk about the notion of on-time performance and why we use that to measure speed in another slide. Now, the great thing about a display like this is if you put a display like this on the wall in a typical team, team members quickly figure out exactly what's being displayed here, and they naturally act to speed up the rate at which they complete work. Now, a skeptic might look at this and say, well, do we decrease quality by increasing speed? And interestingly, the opposite occurs, because a task is not complete until it's bug-free. So there's no incentive here for team members to rush work, because they'll quickly come to discover that having that rushed work results in rework, and rework significantly slows down the rate of work performed by the team. So once we're measuring and visualizing lead times, the job of management is to focus on maximizing speed. And remember, we're trying to adopt pit crew behavior here. So the idea is, if there isn't a task to perform, team members sit idle until there is. When a task arrives, it gets released to a team member or to multiple team members, and those team members sprint to complete it and then go back to standing idle again, waiting for the next task. As I said, pit crew behavior. So what I'm urging you to do is to go department by department within your organization and install pit crew behavior. Customer service, finance, procurement, every department. And in my experience, installing pit crew behavior, switching from optimizing for efficiency to optimizing in speed, tends to have a profound positive effect on the performance of the organization as a whole and profitability. But it's important to recognize that at this point, we're not trying to synchronize the organization as a whole. We're not addressing the root cause of the management problem, which is that it's impossible to calculate locally the global effects of local decisions. And that's what we're about to talk about here. So I'm encouraging you to go department by department and optimize each department for speed by installing pit crew behavior. And a skeptic might argue that this advice was irresponsible because it's likely to cause cost inflation. And in my experience, that isn't the case for a couple of reasons. The first reason is that most managers are not keen to add headcount. We find that we have to pressure them to add team members even when there's obviously a requirement to do so. And the second reason is that if you keep adding team members, you hit rapidly diminishing returns. Now, it surprises many people to know that the Formula One pit crew has 22 team members on it. But an interesting question is, why doesn't it have 30 team members? I suspect a Formula One pit crew doesn't have 30 team members because there's no incremental benefit from adding more team members. In fact, I suspect if you went from 22 to 30 team members on a pit crew, the performance of the pit crew might actually go backwards. So in practice, cost inflation isn't a concern, but of course, in theory, we should be very much concerned with how we're going to synchronize the organization as a whole. So let's talk about how to synchronize the organization as a whole. A logical starting point is the goal of the organization. And at this point I want to introduce you to a book called The Goal, written by an Israeli physicist called 𝗬𝗍𝗲. I suspect most of the folks watching this have read The Goal, but if you haven't and you like this message, you absolutely must go and purchase and read The Goal multiple times. Probably the best-selling business book of all time. So Ely made the point that profit is the goal of the enterprise. Now that isn't exactly the terminology that we used, and it's not strictly correct to say that profit is the goal of a business, but I'm going to adopt that as the goal with a caveat, and we'll come back and correct that later. So let's assume that profit is the goal of an organization, the generation of operating profit, and that everything else is a necessary condition. The difference between a goal and a necessary condition is that a goal is something that we maximize, and a necessary condition is something that we maintain within range. If we think of a car race, lap time is something that we maximize, or minimize in that case, and everything else is a necessary condition, like fuel and tire temperature and oil pressure and so on. Okay, so profit is the goal. Where does profit come from? Well, profit comes from units of value that are generated via transactions. A transaction is when a customer decides that the product or service you're selling is more valuable to them than the money that they have in their checking account. Profit is proportional to the rate at which units of value are generated by the organization. So, if we want to know how much profit an organization is going to make, all we need to do is to determine at what rate is it going to generate value. Now, 𝗬𝗍𝗲𝗱 made an interesting observation. If you work hard to maximize the speed at which your organization operates, you end up discovering that there's a rate limiter that prevents the profitability of your organization from going to infinity. So, of course, every organization has such a rate limiter. He chose to call that rate limiter the constraint. And the constraint is an internal resource that limits the rate at which the organization generates value and therefore generates profitability. Now, I don't want you to think of a constraint the way lean people think of bottlenecks, something to be eliminated. I want you to think of the constraint as a positive thing. I want you to think of the constraint as a source of control and management information. Because the constraint is a single resource that determines the output of the organization, the rate at which the organization makes profit, then if we want to understand the implication of a decision that we're making anywhere in the organization, we can ignore the complexities of the organization and simply focus on the impact that our decision, the course of action we're considering, will have on the constraint. Now, previously I used a Formula One team as an example, and you could argue a Formula One team isn't a great metaphor because of the fact it's a very simple organization. So now I'm going to switch to using an airline as an example. And of course, an airline is a large and complex operation. But I'm going to invoke an airline because airlines tend to do a really good job of understanding the notion of and the implications of a constraint. So let's talk about what an airline does. An airline transfers passengers and freight from one location to another. That's how they add value. That's their fundamental value-generating process, if you like, is that process of transferring people and freight from location to location. Now, the rate at which they do so is determined by the productivity of their fleet of aircraft. And an airline's fleet of aircraft is its constraint. And it's easy to see that because we can recognize that the one resource that an airline seeks to maximize, to fully activate, is its fleet of aircraft. It simply doesn't make sense for an airline to invest in aircraft and have them sitting idle in hangars. So an airline recognizes that if it's going to have one resource that's fully activated, it will be infinitely more profitable or significantly more profitable when its fleet of aircraft is fully activated than it would be when its baggage handlers or its reservation crew are fully activated. And consequently, an airline goes to a lot of trouble to ensure that its aircraft are in the air, to ensure that the seats are full, and to ensure that the holds of those aircraft are packed full of as much freight as possible. And everyone who works in an airline understands the contribution that they're making to maximizing the productivity of the constraint, that fleet of aircraft. So in spite of the fact that an airline is infinitely more complex than a Formula One team, in an airline, operators have the same kind of visibility, the same kind of insight, I should say, into the global implications of the local actions they take. So it turns out that if we're operating an airline, there are two basic operating principles. First is maximize the productivity of the constraint, and second is ensure all other resources subordinate effectively. And we can map these operating principles back to any organization. So by maximizing the productivity of the constraint, I mean that the planes are in the air, that they're full of passengers, and that they're full of freight, and that passengers and the freight providers have paid as much as it's possible to charge them for that freight. Now, ticket price is an interesting study where airlines are concerned. In the 80s, pretty much all the airlines introduced dynamic pricing, and the implication of dynamic pricing is you can sit beside someone on a flight who has accepted a different set of terms when purchasing a ticket and who consequently is paying a different amount, sometimes a significantly different amount for that flight leg than you are. So airlines go to significant effort to maximize the productivity of the constraint, their fleet of aircraft. If you're not contributing to maximizing the productivity of the constraint, then your role in an airline is to subordinate effectively. That might mean, if you're a baggage handler, to empty the baggage from the aircraft and get it to the carousel as rapidly as possible, so as to not waste the value created by the aircraft. If you're in the IT department, it's to ensure that the reservation system is up and running. If you're part of the maintenance crew, it's obviously to ensure that the planes are in the air and flying safely. Now, IT is an interesting study. Southwest Airlines had a catastrophe a few years back where their reservation system went down, and it cost them hundreds of millions of dollars. That, I guess, sent a clear signal to Southwest, but to the airline industry, that it makes sense to have it's essential to have a significant amount of protective capacity at all non-constraint resources. And the implication of that protective capacity is a requirement to embrace what we've already decided to call pit crew behavior. You know, if you're running the IT department looking after an airline reservation system, it doesn't make sense to run that department as efficiently as possible. You want to make sure that you have plenty of capacity, and you want to make sure that you have operators idle, so that if a problem occurs, they can leap to attention and resolve it before it results in a cascade of negative consequences that ultimately result in grounded planes and hundreds of millions of dollars in losses. And of course, these insights don't just apply to an airline, they apply to every business if we're attempting to maximize the speed at which that business operates. I want to double click on speed for a moment. It's just not possible for me to talk to you about speed without also talking to you about variability. Because when it comes to speed, there are two considerations. One is, what's the average time it takes to complete a task? We could call that the lead time. And number two is, if we perform that task repetitively, what's the range of lead times? Now, the range of lead times, in other words, the variability in lead time, is very important in a networked environment. And all of our organizations are networked environments, meaning there are dependencies between resources. In a networked environment, slowdowns are transmitted throughout the network. And in many cases, they're amplified by the design of the network. But speed-ups, the benefit of speed-ups, are lost locally. So in most cases, rather than talking about average lead times, we're talking about on-time performance. The on-time performance gives us an idea of the range. Now, the most common example of on-time performance is on-time delivery performance. If we say that a vendor has 95% on-time delivery performance, it means that in 95% of cases, it delivers stuff on time, and in 5% of cases, it's late. Now, to understand why variability is so important, if we consider a networked environment as pictured here, we have 5 resources with dependencies. The on-time performance of that system as a whole is the product of the individual on-time performances. So what that means is, if we have 70% on-time performance for each of those resources individually, which doesn't look terrible. To calculate the on-time performance of the network as a whole, we multiply them together, which means those 5 resources which individually have 70% on-time performance result in the system as a whole having an on-time performance percentage of 17% on-time performance, which of course is terrible by any measure. So that's why it's so important that you focus on optimizing your organization for speed. Now, it might be tempting for you to look at the airline example and come up with the same objection that you might have done for the Formula One example, and that is that, you know, your business is neither a Formula One team nor is it an airline. And it may be the case that, well, it's almost certainly the case that your business isn't an airline, but it's possible, in fact it's likely, that you're in a situation where either you're not aware of the location of your organization's constraint, or if you are aware, you're also aware of the fact that the constraint moves periodically from location to location within the organization. Now, we know there is a constraint because your organization isn't infinitely profitable. If it were, you wouldn't be watching this presentation. So there's a constraint somewhere. If you don't know where it is, or if the constraint is moving from resource to resource, and practically those two are probably the same thing, then what it means is technically your organization is chaotic. And you don't want your organization to be chaotic because chaos results in a dramatic decrease in productivity relative to the resources that you're paying for. So just like chaos in a road system, in other words, the spontaneous emergence of traffic jams does terrible things to the flow of traffic, chaos in an organization does terrible things to the productivity of the organization or the profitability of the organization. So you don't want your organization to be chaotic. So for that reason, you want to invest the necessary effort to figure out what resource is your constraint. And I think the easiest way to do that is to start by identifying what I'm calling the fundamental value generating process. And then ask yourself not what is the constraint, but which resource within that process should be the constraint. In other words, if you were going to consistently fully activate one resource, what would that resource be? If you have a paint and panel shop, for example, it's almost certainly going to be the spray booth. If you have a cabinetry shop, it's almost certainly going to be the spray line. There's just something interesting about paint and other finishes. They tend to be the limiting factors in production environments that contain them. But it's very important that you examine your organization and figure out what is the primary value generating process and what is or what should be the rate limiting resource. Because once you can identify the constraint dictates the performance indicators for every other department and every other individual organization-wide. And as I said, if you find this conversation interesting, you should really get yourself a copy of Ellie Goldratt's book, The Goal, if you haven't read it already. Which brings me to part 3 of our discussion, and that's the requirement for 2 discrete systems. It turns out that the goal of a business is not actually to maximize profit, it's to maximize enterprise value. And enterprise value is a function of both operating profit and growth. And that has interesting implications for the architecture of our organization. And I'll get to that in a moment, because I have a brief ad break first. So I'd like to encourage you to request a proposal for what we call a detailed design workshop. A detailed design workshop is a workshop presented or facilitated by me with your senior leadership team in your boardroom, your executive suite, wherever you are on the planet within reason. It's a one-day workshop, and the purpose of the one-day workshop is, number one, to design a model for your organization that's supportive of the speed-based operating system, and number 2, to develop a detailed transition plan to help you make the transition from the cost-based operating system to the speed-based operating system without any disruption to business as usual. So to get the proposal, all you have to do is write the word proposal either in the comment section of LinkedIn or DM me if you'd like to contact me privately. Just send me the word proposal or speed-based operating system proposal, and I will get that proposal to you. The workshop, for the record, is surprisingly inexpensive. We charge organizations just $3,000 to run the one-day speed-based operating system workshop, our detailed design workshop, which is significantly less than my normal standard day rate. So yeah, write the word proposal in the comments section, and we'll get one to you same day, almost certainly. Okay, back to part 3 of your transition plan. As I mentioned, enterprise value is a function of operating profit and growth. If you've read the goal, returning to that book for a moment, you'll remember Ellie said that the goal of the organization is to make money now and in the future. So him and I are saying the same thing. When I say the goal of the organization is to maximize enterprise value is how much money you make today as well as how much money you make in the future. If you look at the price of an organization, whether it's the share price of a public company or whether it's the price that you can sell your private company for, the price is a function of the operating profit that it generates today, plus an expectation of how much operating profit it will generate in the future. Where public companies are concerned, we talk about the price-earnings ratio, which is which highlights the difference between the price and the current earnings. And where private companies are concerned, we talk about the multiple. If we sell a business today, we earn a multiple of current operating profits. That multiple varies in size from maybe 3 times to perhaps 10 times or even more in some cases, based upon the growth of the organization. In other words, based upon the potential for future earnings. So our goal as leaders is to maximize enterprise value. And as I mentioned, it's very important that the architecture of your organization reflects that goal. It's a 2-part goal. We want to maximize profit today, and we want to also maximize the growth of the organization. So we're trying to maximize for 2 parameters simultaneously, which is impossible within the one system. The solution to that is not to have one system, is to divide the system into 2 subsystems, which is exactly what my recommendation is. In order for you to build a successful business, your business needs to consist of 2 subsystems. The first is what I call the business as usual system, the goal of which is to generate operating profit. And the second system is what I call the growth system, the goal of which is to generate growth in operating profit. Now, the reason I'm saying 2 systems is these 2 systems need to be discrete. By discrete, I mean loosely coupled, and by loosely coupled, I mean they must have no shared resources. If they have shared resources, you will have resource contention. And in the case of resource contention, business as usual will always win. I'll give you 2 examples. If you have salespeople who are responsible for managing customer accounts at the same time that they're responsible for the pursuit of new accounts, you will find that they neglect the latter in order to perform the former. And after 30 years of going into businesses, listening to the complaints of executives, I can say with absolute certainty, if you give salespeople responsibility for managing accounts and pursuing new ones, you will be unhappy with the rate at which they pursue new accounts. Another example would be engineering. If you have engineers who are responsible for designing customer solutions at the same time as they're responsible for new product development, you will be dissatisfied with the rate of new product development because the design of solutions for customers will suck all of the oxygen out of the room. And of course, if you combine this with the traditional cost-based operating system where teams are optimized for efficiency, that just exacerbates the problem. So you need to split your organization into 2 discrete systems, loosely coupled. If you absolutely must have shared resources, those shared resources must have a ton of protective capacity, and those resources must be formally scheduled so as to avoid the unpleasant effects of resource contention. Okay, so let's explore the makeup of both of these subsystems. The first is the business as usual system. The purpose of the business as usual system is to generate operating profit. And for the purpose of this discussion, I'm going to visualize it as a simple process. At one end of the process, the input is inquiries, and at the other end of the process is delivery. So what that maps to in the organization is customer service, who are receiving inquiries, and we have the operational process there that stretches from an inquiry to delivery. So that includes, planning and procurement, engineering, production, and delivery. Fulfillment. That is the process that generates operating profit. Now, you might be asking, well, where are salespeople in this process? My argument is that salespeople do not belong in this process. Salespeople belong in the growth system, which I'll get to in a moment. The role of salespeople is to generate a basket of annuities. And that basket of annuities yields inquiries. That's the output from the annuity. So the job of salespeople is to win customer accounts and to load them into that bucket, and that bucket of customer accounts generates annuities. Or in the case of a B2C environment, business to consumer environment, the job of the marketing department is to build a market reputation, and that market reputation results, goodwill if you like, results in a natural flow of inquiries. So business as usual stretches from customer service through fulfillment. And the job of business as usual is to generate operating profit. It does not include sales. Now that brings us to the growth system. The growth system, as I've already mentioned, includes sales, but it includes the other parts of the organization that are responsible for growth. So let's talk about growth. Growth comes from new customers, we all know that, but also from new products, new territories, and from acquisitions. So my suggestion is that we should package together all of the departments, all of the groups within your organization, all of the functions within your organization that are responsible for growth into the one group. And we should ensure that that group functions separately from business as usual, and that it has its own discrete resource pool. So if we talk about specific resources, we have sales, who are responsible for hunting for new accounts and for cross-selling existing accounts, new products. We have new product development and product management. Product management is responsible for the life cycle of product segments, and new product development is responsible for developing new products, obviously. And then we have an acquisitions team that's responsible for acquiring new business. All of these should be grouped together. They should operate with their own cadence. They should have their own constraint, and they should be managed as a discrete system separate from business as usual. Now, this type of structure is exactly what you find if you go and look at fast growth technology companies in Silicon Valley. But if you want to build a fast growth traditional business, or even a moderate growth traditional business, this is exactly the architecture that you should be moving your organization towards. Okay, so I've introduced you to the three critical attributes of the speed-based operating system. I've given you a practical overview of those three elements and talked to you about what you need to do to make the transition. But I want to return, before I leave you here today, to a point that I made at the beginning of this discussion here. It's important for you to have a academic, if you like, understanding of the speed-based operating system, but it's also important that you don't get paralyzed by the complexity around synchronization and discrete subsystems and fail to exploit the obvious and easy potential that comes from installing pit crew behavior in each of your departments. I think if you can identify which resource in your organization is the constraint, what you want to do is determine the departments that have the most significant impact on the constraint, rank them, and go and work on those departments in that order and install pit crew behavior in each of those departments. Packetize work, choke the release, put a dashboard up in every room that visualizes the rate at which work is being completed, and insist that operators stand idle until there's work to be performed, at which point they can sprint to complete it and return to standing idle again. Pit crew behavior. Do it today. In my experience, the benefits of doing this are significant, money in the bank. I hope this workshop's been beneficial for you. If you're interested in continuing this discussion, you can write the word proposal in the comment feed and we'll send you a copy of the proposal for the detailed design workshop. Thank you for joining me here today and good luck.